Back, everyone. This is another episode of the Ramda Deep Dive Season 2. Um, we're going to look at forEach today, and I've already taken a look at the next few functions. And I, when I first looked at forEach, I thought it was kind of strange that it was in this library. Uh, forEach, which is a built-in method on the array object, you use it for things like consoling or side effects like sending emails for a bunch of names in a list or doing a bunch of fetch requests or whatever, but it doesn't return anything, and that's what's strange. Like, why would you have this in here? But of course the for each in Ramda works a little differently. Um, so let's start by reading in the description. So we're going to iterate over a list, input list, and call a provided function for each element in the list. So it does what it says. Um, but what's interesting is that the Ramda for each does not skip deleted or unassigned indices, or also called sparse arrays, unlike the native array for each method. For more details, you can go and click this. And there are actually several ways that you can end up with an array with unassigned indices. Well, that's hard to say. um, Basically holes in your array. So we'll look at that. Um, and then here, unlike the built-in for each method, Randos for each returns the original array. And in some libraries, this is called each. Um, I'm not going to worry about in this series dispatches to the for each method of the second argument if present. That's behavior uh, seems to apply to a lot of functions. And maybe at the end, we'll take a look at that just all together in one video. Um, and then we'll just review add index because we've looked at that. That was one of the first functions in the original series. Um, but before we look at a demo, let's take a look at the type signature. So it's pretty straightforward. It takes a function that takes anything. It's going to be whatever list you provide. That's the thing that's going to be the provided as the first argument to the function. And then it can do whatever. It can return anything, or I actually it doesn't really return anything. It just does a side effect. That's what this function is. You could return something, I guess, but well, no, you can't because the second argument is the list you're going to provide, the list that you're going to do something for each element in the list. And this A is the element in the list as you're calling it, as you're calling the function each time. But then it returns this same exact list, like unmodified. I guess it's more correct to say it would return a new list, because we're not mutating. But I don't know. In this situation, let's see, it returns the original array. So maybe it doesn't return a copy of it. Maybe it actually just does pass the array through. Um, I mean, in practice, it doesn't matter, but I was just wondering. Um, so in a lot of respects, this is like the identity function where you can also run a side effect, you know, before you pass the item back to the new list. Um, that may not make a lot of sense. So let's go in here and look at an example. Um, First, I think it would be cool to see how we could use other random functions we've looked at to recreate our own for each. So let's do that. Let's make a function called for each. And what we would need to do is we need to pass the function to it. And then we would need to pass a list. And yeah, we'll pass this x's in here. I'll call it x's here as well. And then, so it we pass in a list and it returns back the list, right? So that's just like our data identity. I think that will work. Let's see, for each exit. Oh, wait. No. Let me think about this. It's going to return the X's. Yeah, so for each, and then I don't think it even matters. We could just pass null. I expected to get the original array. Uh, oh, I see. We've got to pass, we've got it curried, so we've got to pass the data to it, right? Yeah. So like that's half of what it does. We pass in an array, a function, an array, and it gives us that same array back. So it's really just like the identity function, you know, in practice, as far as the result that you get back. But if we return this, the whole thing is it would be basically mapping the function, right, on, yeah, it would just be mapping the function. So if we pass in a function, I'll just do it in line and say x times 2, or here, let's do a random function. So run Ramda multiply 2. Of course, map. Oh, r dot map. Uh, Clear this console, run it again. Yeah, it's not multiplying. Maybe I need to, why not? Multiply 2. I mean, I'm already on a sidetrack. We're not looking at the random for each, but I think it's nice to figure out how you would do it by hand and then learn how to use the conveniently made for each like they have. But I feel like this should work. So for each, I'm passing the function multiply by 2, partially applied, and then I pass it the data. And I mean, this is the same as, oh, yeah, I've got to give it the x's to map over. Ah, I'm not logging it, and that's the other thing. Um, so this is a side effect. In fact, let's pass it like this. And get an error. That's a strange one. Function punctuator. Let me do it like this. Look at that cryptic. If function is not a function, log. Oh, I see. Because I'm partially applying it, I can't log it right there. Let me log it here. Maybe that'll work. Yeah, it does. Okay, let me clear the log. So, I mean, that's a really roundabout way to do it. But what I'm doing is I'm like console logging. Um, I'm using map, and map is going to return an array, but it's just returning it into the void. Like we're not doing anything with it. And and so we pass the x's and we use the x's as our log, and then we just return the x's at the end. So it's like side effect, and then if the side effect was gone, it would have the same general effect as using the identity function in just a convoluted way. Yeah. Okay. But and the reason we're getting two logs here in this first one is that we're logging it in here, but we're also logging this whole function call. So if that's confusing, ignore this that bit. We'll just look at for each by itself, like the actual Ramda for each. So to do all that convoluted business, we could just say r dot for each, and then pass it our callback function. I'm just going to log it, and then our list. Yeah. And so here's the log that's happening for each item in the list. And then at the end, we're returning the original list because of this outer log. Um, so it's pretty handy. And what's cool, it says that it, unlike the built-in one, where is it? It does not skip the deleted or unassigned things in the array. So like if we just did this, and first if we just log that array, do it again like that. See, we had the one, two empty item. I like you would think it would be undefined or null or something, but now here's this like whole other concept of empty in JavaScript. It's just so many different things. But they say it doesn't skip it. So what would happen if we tried to map over each one? Like r dot, what am I trying to do for each? And we passed it. Um, I want to do something to it. Let me think how I would do that. The second argument is going to be x's. The first one, well, let's just say log yo. We'll just doesn't depend on the value, just how many items. So it should do it 5 times, right? Oh, didn't like that. Got that same thing again. I mean, if I do it like this, yeah, yeah, because it wasn't really a point. Yeah, I couldn't call it like that. It wants a callback function. I couldn't invoke it right away. Uh, but see here, it logged it yo 5 times. Now, like, what if we go back to the native one and logged x's dot for each, like the built-in JavaScript, and then we pass it the function, which was what, log something? Uh, let's see what that does. See, it only did it 4 times, and then we get this undefined. And what's worse is the undefined is the last value, but the one that's like not in there is it's in the middle. Like, and this makes it looks like there's something wrong at the end, or not wrong, but like missing. or something. Extremely annoying. So that's very cool that for each handles that situation. Um, Otherwise, I mean, you got to do side effects at some point, and at some point you're going to need to do fetch requests, and sometimes you can still just use a map, even though it's not returning anything. Um, it's up to you, whichever you want to do. And then see also add index. Just briefly look back at that one. Um, Crazy signature, but remember, it just adds the index and the array to the loop, I guess I should say. So just real quick, let's make one and call it for each indexed, and then we would just apply add index to um, r dot for each. And so now we have this function. Let's see, we just log it. We'll say for each index, and we'll just do that console log yo and pass it the array. We don't need to log this because we're logging inside the callback function. Right, so that still works, but we could also, so here we're getting the item. So let's log the item. And just to be explicit, I'm gonna put these on different lines, get rid of that and that, and then we can name these arguments. So we're gonna have our the element, we're gonna have the index, and we're gonna have the array. And then we can just console log out all of those things. Element, index, and the array. Yeah, so here we go. The first time it's one, is one, it's two, and then the third one is it's undefined, which is I guess what they do with this empty element. They turn it into undefined, which makes a lot more sense. And then zero, one, two, those are the indexes, and then of course each time it's showing you the original array. Um, so if you need those things, you can do that. Yeah, so that's for each. Um, let's look at their example real quick too, just because it may be easier to understand than the ones I'm thinking of on the fly. So we have this function called print x plus 5, takes x and console logs x plus 5. And we're calling that here. Here's our array. So let's pass in our own array. This one up here. And then we don't need to log it because it's being logged here. Yeah, and 6, 7, and then not a number because and undefined plus 5 is not a number, I believe. And then 9 and 10. Check. Can I just say? I guess I have to say node defined plus 5. Does that work? I'll put it in parentheses just in case. Okay, no, that's not how you do it. Uh, I mean, that's not right. No, I don't know how to do. Just run a command. Like, how do you get into the? Oh, well, just log it. I just want to make sure that it is turning into value to undefined before it tries to add to it. So just do that. Oh, yeah, yeah, not a number. That's what that does. But still don't like not a number. I think it should just be undefined or throw an error or something, but they didn't ask me. Anyway, that's for each. Next, we'll look at for each object indexed, which is just like another kind of more specialized version of for each. And thanks for spending your time with me and tell a friend, and I'll see you in the next video.